Have you ever wondered how you could add caching to your simple repository pattern in C#? Hi, my name is Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In this video, we're going to be looking at adding simple caching using IMemoryCache to our repository pattern using Entity Framework Core. And I realize it's a mouthful, but this is part of a video series where we're looking at the repository pattern, we're looking at different implementations of that, and now we're going to start to layer in caching. In the previous videos that I made on this, which I'll link up here, we're going to be talking about how we're using Entity Framework Core with a repository pattern. Now, many people aren't a big fan of this, and they already feel that Entity Framework Core kind of gives them what they need. The repository pattern is just a bit too much abstraction on top of that. But in this video, we're going to be looking at leveraging that pattern and then trying to incorporate caching as well. Now, the caching in this video will be using the simple IMemoryCache in C#, and in follow-up videos as part of this playlist, we'll be exploring different implementations of caches. So if that sounds interesting, just a reminder to subscribe to the channel and check out that pinned comment for my courses on Dometrain. Let's jump over to Visual Studio and look at some code. Okay, this application is based on the previous videos, so again, if you haven't gone ahead and watched some of them in the beginning, we can go ahead and have a link up here and you can check that out so you understand some of the basics of Entity Framework Core and the repository pattern. To kick things off though, on line 4, we're looking at adding dependency injection for leveraging our repository. But there's going to be a difference because this line 4 here, so set up Entity Framework CRUD generic, and that was going to give us a repository using Entity Framework Core with simple create, read, update, and delete. That's what CRUD is. And that's going to back all of these methods that we have on our minimal APIs here. So again, disclaimer for the folks that have not gone and watched the other videos, this is not how I would recommend making a CRUD app. This is a bunch of get methods, which I don't recommend you do, but I'm going to show you in the browser, and I just wanted to make it very easy to hit the routes that we have here. So to kick things off, though, we're going to explore a different setup here. I'm jumping into what we had previously, and we're going to look at this variation instead. So very, very similar, right? You can see that between here and here, this part's identical just for adding our DB context factory. Yes, we're going to be using SQLite if I didn't mention that already. Same thing as in the previous videos. And then you'll notice that here's the only difference, right? So I'm just adding in a different implementation. If I quickly jump over to this generic implementation that we had before, this is just a repository pattern. So we have this iRepository interface. We have that around our database context from Entity Framework Core. So you'll notice that in all of these method calls, we're getting a DB context. We're doing something with Entity Framework Core. So really just one more level of abstraction. And if you're looking at these going, these are too simple, I would just call this stuff in Entity Framework Core anyway. That's totally okay. I'm not here to convince you that you have to go use a repository. I'm saying this in every video, just showing you how you can go implement these things if you'd like to. But if we jump back, we're going to look at a different implementation. Very, very similar, but it's also going to take in an IMemoryCache. So if we jump in, we're going to see that like the other one, it takes in this IDB context factory, but we're also going to have an IMemoryCache, right? So between the constructor and these fields getting set, this is going to enable us to start adding caching to all of the different API calls we have. To start things off, if we look at our get method, this is going to have a little bit of extra code in here, and that's just because we're going to have the caching operation around what we had in the previous implementation. So right in here, this is essentially these 4 lines of code is what was in the previous implementation, right? Everything else inside this method is just to support caching. So we say to the memory cache that we would like to get or create an entry asynchronously. The next part is that we need a key. So when you're creating a cache, you need to think about how you're going to key on the individual elements that are in your cache. Because our repository is very simple, it's just using entity types that have an ID on them, we are just going to be using the key as the ID for that entity. And that way, if we want to go get a particular entity and it's already in our cache, we can just fetch it very quickly without going to the database. But before we move on, this is just a reminder that I do have courses available on Dometrain if you want to level up in your C# programming. If you head over to Dometrain, you can see that I have a course bundle that has my Getting Started and Deep Dive courses on C#. Between the two of these, that's 11 hours of programming in the C# language, taking you from absolutely no programming experience to being able to build basic applications. You'll learn everything about variables, loops, a bit of async programming, and object-oriented programming as well. Make sure to check it out. If we look at the other part here, this is just to illustrate that we can add an expiration on here. So this line is not necessary, but if you wanted to play around with this kind of thing, then you can set different expirations, and there's some other features that you can enable and play with on the memory cache. So just a heads up, not needed, but just something that you can explore if you're interested in. The idea behind here, and I want to spend just a moment on this, it's not super applicable to the IMemoryCache, but if you were to think about what this does, right, it's get or create. If you were thinking about this in a very simple way, what you might do is say, hey cache, do you have an entry that is for this ID? And then it would check, and then it would come back and say yes or no. If it had it, then it would say, yes, I do, and then you could say, great, thanks cache, give me that entry then. So you're kind of doing a check and then a get for that entry. The other thing that could be happening here is the cache says, no, I don't have that entry, and you go, great, 1 sec, let me go to the database. And then from there, when I get the record back from the database, hey cache, I would like you to go store this. Again, it's breaking it into multiple operations. This API that we have access to, get or create, is a common pattern you'll see when working with caches. The idea behind this API is that it's structured in a way to sort of combine these operations for you. That way, based on the API, it should be able to try and offer things like Stampede protection. From my usage with the IMemoryCache implementation, though, that's built in, I have not seen it offer Stampede protection. And if you're wondering what Stampede protection is, it's this idea that if you have multiple things in the same process, let's say, they're trying to come into the cache and saying, hey, do you have this entry for me? Right? If you had 100 different requests coming in parallel, what would be able to happen is that they would go into this method and there would be an opportunity to only allow one of them to go through to the downstream service, in this case, the database, to be able to say, hey, go get that record and fetch it, instead of 100 things stampeding the downstream resource. Now, in distributed systems, something like this is not going to work unless you're doing some type of synchronization across. But if you imagine, again, just for the sake of simplicity here, that if you had 10 servers, each getting 100 requests coming in each, right? So you have a total of 1,000 requests. Each of those 10 servers might let through one if they were coming through in parallel. So you have 10 requests getting through instead of all 1,000. It is some improvement. It's just not a guarantee. But with the IMemoryCache, again, from my experience so far at the time of recording this, I have not seen that it actually offers Stampede protection. There are other implementations of caches that we will look at in future videos that do offer this, and we can actually go play around with this as well. So just wanted to mention, that's why we generally see an API like this. It's to combine the check and then being able to either get it back or set the entry in the cache. Overall, pretty simple though, because this part here is the same exact code that was in the other repository. I'm going to come back to get all in just a moment. I'd like to go through the other entries that we have here for the different methods on a repository. So if we look at the create method, this part here is exactly what we had in the other repository, but you'll notice I have 2 lines commented out. Now, when we're doing something like creating an entry, what we could do is decide just to invalidate the cache. We could say, hey, if there was something here, we could go remove it. But the odds are that if you're creating something and that ID is already there, this is probably an issue. So at the create call path, this is probably not something that would ever really make sense. But the other thing that we have down here is to be able to set it. So the option that we have to work with here is that when we are trying to write something into the database, we can make a decision if we want to also write that to the cache at the same time. Now, this might be expensive in some cases, depending on your caching mechanism, depending on how much you're writing, but this is a design decision that you have to think about. If you go back up to our get method, right, every time we're trying to read something from the database, we're going to store it in the cache. Do you also need it every time you're writing? Or do you only need it when you're writing? So you have to think about how your data is flowing through your system, if you're read heavy versus write heavy, and other considerations for caching. Because this is a very simple example, I'm not going to include writing to the cache when we write to the database. And like I was saying, the remove on the cache doesn't really make a lot of sense when we're creating a new entry. There shouldn't be something in the cache anyway. But if we want to, just for consistency and to make sure that if there was something in the cache that we invalidate that entry, we can go ahead and remove it from the memory cache. It's just that realistically, this is probably not going to do anything effective for us. Now, let's explore something a little bit more interesting, right? So we have this update async method. This is going to be a little bit different than the create one. So the rest of the code that you see in here that's not commented out, so ignore line 70 for just a moment. All this code that I have highlighted, except line 70, is going to be the same code that we have in the original repository. But we have the same caching question like we were looking at with the create. The difference, though, is that if we are in fact updating the repository, we can invalidate the cache, like so. So this means that if we are going to go write a new value in for this particular entity, we can say, hey, look, if there was something in the cache, just blow it away. That's one option we have. The other option, like we were talking about with create, is once you create that entry, could just go set that in the cache now? But depending on what your needs are in your caching implementation, you could say every time I want to go update something, maybe depending on how your app or service performs using this repository, it's maybe very likely that you're going to be reading this back soon. So you do want to have it cached. It's not going to be for me to decide. I'm just trying to show you that you have some different options here. So again, in this example, I'm just going to leave it out, but we're going to invalidate the cache if we update an entry. So that means the next read for that particular entry, again, we're looking at the ID as the key here. If you want to go read that back, it will go to the database one more time and then cache it. What we're looking at so far in all of these examples is that the get will end up putting something into the cache, and anytime we're doing some type of write, we're going to be invalidating or removing the entry from the memory cache. Finally, in the last method for delete, it's going to be very similar, but there's nothing to update, right? We're actually removing something entirely. So in this case, we just have this single remove line to remove a possible entry from the cache, but the rest of the code that you see in here is in fact the same as the other implementation. Hopefully that makes sense, but we had one that we skipped over, and that's GetAllAsync. This is something I wanted to pause to talk about because this is one of those opportunities where when people say, hey, like I just want to copy this code, or hey, can you just push this up because I just want to copy and paste the code into my own stuff. I don't recommend doing that ever because I want you to understand these types of things. You can pause the video and type out the code or see how it's flowing, but if you're just going to copy and paste this, I don't think that there's a ton of value, especially if I would have filled this one out. So let's think about this for a second. I don't know what kind of application you're building, right? I have literally no idea. So if you're thinking, hey, this generic repository with caching, that seems like it's going to be a really good fit, but you have something that has 1 million products in a database. And then we talk about caching these things, and I go implement it, and you read back all of the entries, and you go put every single one of them into the cache. What's going to happen? It's the same story that I had in the previous videos where I was talking about this being a materialized collection. If you call GetAllAsync and pull in 1 million records for your products database, and you put them all into some read-only collection, it's not going to be a good time. Instead of me just having a blanket dummy implementation here that's going to cache everything or something else like that, I just want you to think about what your needs are. If you're dealing with very small repositories, right? Maybe you have something that's blog posts, and on your site, you're like, I'm only ever going to have 100 blog posts. Sure, maybe you just want to cache them all, and you have enough memory to do so, and that's cool. Maybe the blog entities are actually small because they don't even have all of the content for the blog posts themselves. However it's designed, if you only have a small number of these things, maybe it makes sense to have them all pulled into memory, all cached, and that way any read is very effective. I literally cannot say because I don't know what you're building. So I would rather take this opportunity instead of just having some blanket code that you're going to go copy and paste, kind of take a break here to say, please think about what you're caching, because that is going to have a memory footprint. I hope that makes sense. Sorry that there's no code called out here for caching. If you wanted to try and cache entries, you need to think about how they're going to be retrieved, because in this case, what we were doing was every other entry was keyed by the ID, right? So this is not keying by IDs. In fact, if we wanted to use the cache when we were reading this, is that really going to help us? They're only keyed by IDs right now. Would we have another cache entry that was keyed by like a special other key that said all, and we could just look at that? Would we use another cache altogether? Would we try to read back everything, put each individual item in the cache by its ID? That means that anytime we call getAll, it's going to be always hitting the database, but any individual gets fast. Do we do something even more complicated where we say, okay, getAll will store all of the entries into the cache, and we'll set a flag that says, the cache is full of all the entries, and then we have to make that a dirty flag if someone writes something. This can get ridiculously complicated very fast, depending on what you want to do. So what I've done in this video is, of course, I've showed you the very simple use cases across these other methods, but you'll notice that as soon as you start to deviate a little bit, this is where you'll start to say, I really need to think more about what I'm doing here because this will have consequences. So again, just wanted to take this moment to pause on this part so that you can think a little bit more deeply about what you're trying to do. Because just copying and pasting stuff and just saying, some bald guy on the internet said it was a good idea, it's not. Do think about how you would like to cache this stuff. I'll give you one quick example that in the Blazor blog engine that I'm using from Steven Giesel, he actually has a very similar implementation to all of this, but we are not putting any caching on the getAll calls. It's like we've optimized the other call paths, but this one, it's okay. It's going to take a little bit longer. It's very rare that we're calling this to get everything for a particular table out of the database. Just a couple of variations. But enough blabbing. You probably want to see this thing run. So let's go ahead and go over to our program.cs. We'll make sure that we set up the caching one. Boom. So we have that in place. But one more thing before we go ahead and run this is that we've set these things up here to be able to use our caching entity framework core repository, but we still need to add in the memory cache. So we can use builder.services.add_memory_cache, and this is going to be the dependency injection line that we need to get memory cache added. Again, this is just the built-in one. It's not a third-party library or anything like that. Nothing too crazy, but let's go ahead and run this and try it out. Okay, so I have things running. I have SQLite Expert pulled up here. We're going to go look at this record down here that ends in 7930, and I'm going to go ask for it from the repository. You can see that we ended up getting the record. It has test as the value. Watch what happens when I press enter though. It might be hard to see, but do you see how fast it's coming back, right? The other thing that might not be obvious is if I look down here inside of Visual Studio, if I highlight in the bottom in the console, you can see that it did a select, right? Select e.id, e.value from entities. But every other time I make a call here, it's not doing the SQL command anymore. If instead I go pick another one, so this one ends in 3.1, so let's go ahead and run that. Let's watch the SQL at the bottom though. You can see that it went and did another SQL command. If I press enter on this one now, it's hitting the cache. It's not actually going to the database anymore. Let's go back to this one, still cached. You don't see any more SQL being written out to the console. That's pretty handy, but the create call is going to call remove from the cache, which isn't going to be helpful for us because it's not going to remove anything that exists already. Then we can try update, and we should see that when we do an update to this entry, that the next time we go to fetch it, it has to hit the database again, right? So if I press enter, it's still not going to the database, but if I do update, and then I say, and value equals dev leader. So we see that it ended up running some SQL to update it. But now if I want to go fetch it, we should see that this will go run more SQL to hit the database. And there we go. It pulled it back. It says dev leader, but next time I press enter, right, no more going to the database. This is just a very simple example of a repository pattern, wrapping up Entity Framework Core and using the IMemoryCache. But there's something interesting that if you were paying attention to as I was going through this, you might have noticed that I said, hey look, this code is the same as the other repository. In this next video, which I'll put up here and add to the playlist, you can see how we can use the decorator pattern to go do this a little bit more easily. Thanks, and I'll see you in the next video.